Salt Lake City, Utah, the United States of America. The Great Salt Lake, the largest saltwater lake in the Western Hemisphere, is facing an unprecedented crisis. In 2022, this vital body of water dropped to its lowest recorded levels, prompting researchers at Portland State University to conduct the first comprehensive study of its decline. The significance of this crisis extends far beyond the lake's shores. The Great Salt Lake generates approximately $1.9 billion in annual economic revenue, serves as a crucial feeding ground for millions of migratory birds, and plays a vital role in enhancing snowfall over the Wasatch Mountain Range. With Salt Lake City set to host the Winter Olympics in 2034, understanding and addressing this decline has become increasingly urgent. Led by PhD candidate Siiri Bigalki, researchers developed a sophisticated model to track annual water volume fluctuations in the lake. Their analysis revealed two primary factors contributing to the lake's shrinking size. The first and most significant factor, accounting for approximately two-thirds of the water loss, is reduced stream flow from the lake's three major tributaries. This reduction stems from a combination of drought, water diversions, and climate change impacts. However, the study identified a second crucial factor that had been previously underestimated: increased evaporation due to rising temperatures. The research demonstrates that without this warming trend, the lake would not have reached its record low in 2022. This finding is particularly concerning as climate change continues to accelerate, potentially intensifying the evaporation process in the years ahead. The implications of this decline are far-reaching and potentially severe. For the 1.2 million residents of the Salt Lake City metropolitan area, the shrinking lake poses significant health risks. As water levels drop, more lake bed is exposed, increasing the likelihood of dust events that could carry toxic particles into populated areas and degrade air quality. The economic impact extends to multiple sectors. The lake's influence on local weather patterns, particularly snowfall in the Wasatch Range, is crucial for the region's 11 ski resorts and winter tourism industry. A compromised lake could have extensive repercussions for these economic drivers. While short-term solutions such as water conservation measures might help the lake recover some of its lost volume, the long-term outlook is more challenging. The escalating heat associated with climate change is expected to further intensify evaporation, potentially outpacing any near-term improvements in water management. The research team emphasizes the need for further study to determine precisely how each factor, rising evaporation, shifting precipitation patterns, and human water usage affects the lake's water levels. This understanding is crucial for developing effective policies to address the ongoing decline. The Great Salt Lake's crisis serves as a stark reminder of the complex interplay between climate change and resource management. The solution will require a coordinated effort from policymakers, conservationists, and local stakeholders to balance economic demands with ecological sustainability. As we look to the future, the preservation of the Great Salt Lake depends on implementing measures that address water scarcity, regulate water diversions, and mitigate the effects of global warming. The findings from this research underscore the urgency of these efforts and the potential consequences of delayed action. The time to act is now, before this vital ecosystem reaches a point of no return. For more on this story, find a link to the article on Earth.com in the description.